Space and Science News with James. Welcome to a world where we can potentially reprogram our immune system, teaching it to fight cancer more effectively or to stop attacking our own bodies in autoimmune diseases. We're on the brink of a medical revolution where nanoparticles, microscopic marvels thousands of times smaller than a human hair, are reshaping how we approach healthcare. These tiny particles are opening doors we never knew existed, challenging everything we thought we understood about our immune system. Today, we'll be talking about the impact of nanoparticles on the immune system because, why not? This field is bursting with potential, promising to transform healthcare as we know it. But it's not all straightforward. These engineered particles also raise significant questions and concerns. What happens when these tiny particles meet our body's natural defenses? Can we truly control these interactions, or are we venturing into unknown territory? And what unforeseen consequences might arise as we explore this exciting frontier? Let's dive deep into this subject and unravel the complex dance between nanoparticles and our immune system. What you're about to learn could change your perspective on the future of medicine forever. Welcome to our exploration of the fascinating world where nanotechnology meets immunology. Today, we're diving deep into the impact of nanoparticles on the immune system, a critical area of research in the rapidly evolving field of nanomedicine. Nanoparticles, those tiny particles measuring between 1 and 100 nanometers, have opened up exciting new possibilities in medicine. They are not just small, they are revolutionary. From targeted drug delivery to advanced diagnostic tools, these microscopic marvels are transforming healthcare in ways we could only dream of just a few years ago. However, as with any groundbreaking technology, nanoparticles come with their own set of challenges and unknowns, particularly when it comes to their interaction with our body's defense mechanisms. Our immune system is a complex network of cells, tissues, and organs that serves as our body's frontline defense against foreign invaders. It's always on high alert, ready to identify and neutralize potential threats. But what happens when this vigilant system encounters engineered nanoparticles? Do these tiny particles slip by unnoticed, or do they trigger an immune response? And if they do provoke a reaction, is it beneficial or harmful? These questions lie at the heart of what researchers refer to as the gray zone of nanomedicine, an area where the boundaries between friend and foe, therapeutic and toxic, become increasingly blurred. Understanding these interactions is crucial not only for developing safe and effective nanoparticle-based therapies but also for predicting and managing potential side effects that could arise from their use. In the next few minutes, we will explore the intricate dance between nanoparticles and the immune system. We'll delve into how different properties of nanoparticles can influence immune responses and how scientists are harnessing these interactions for groundbreaking medical breakthroughs. Along the way, we'll also examine the challenges and potential risks associated with using nanoparticles in medicine. So, let's embark on this microscopic journey together and unravel the complexities of nanoparticle immune system interactions. The insights we gain may just change how we think about health and disease in the future. When tiny particles called nanoparticles enter our body, they first encounter our innate immune system. This system is like a vigilant security guard, always on the lookout for anything unfamiliar. It doesn't discriminate, it treats all newcomers with equal suspicion. Think of these nanoparticles as tiny explorers navigating through our bloodstream. As they float along, they meet a group of proteins called the complement system. These proteins are like sticky labels that attach to the nanoparticles, marking them as foreign. This process, called opsonization, is like putting a big, handle with care sticker on a package. Next, our body's cleanup crew, the macrophages, spot these labeled nanoparticles. Macrophages are like Pac-Man characters, gobbling up anything marked as foreign. They try to engulf and break down the nanoparticles in a process called phagocytosis. It's like our body's way of eating unwanted visitors. But here's where it gets interesting. The size and shape of nanoparticles can affect how easily macrophages can eat them. Think of it like trying to eat different sized and shaped candies, some are easier to swallow than others. Some nanoparticles might even change how macrophages behave, either revving up their activity or calming them down. Another key player in this drama is the neutrophil, the most common type of white blood cell in our body. These cells are like first responders, rushing to where the nanoparticles are detected. They can engulf nanoparticles too, but they have an extra trick: they can shoot out web-like structures to trap the nanoparticles, like a spider catching flies. Understanding how nanoparticles interact with our innate immune system is crucial for scientists. It's like learning the rules of a new game. By tweaking the properties of nanoparticles, researchers hope to control how they interact with our immune cells. This could lead to better treatments, where nanoparticles either sneak past our immune system or work with it to fight diseases. It's a delicate balance, but one that could revolutionize how we treat many illnesses. Consider your body as a fortress equipped with two distinct defense systems. We've talked about the first one, the innate immune system, which is like the guards at the gate who stop any intruder they see. Now, let's explore the second line of defense, the adaptive immune system. This system is like a team of special agents who take time to study the intruder and create a tailored plan to fight it off. When nanoparticles enter our body, they might encounter this adaptive immune system. Unlike the quick-reacting innate system, the adaptive system takes its time to develop a specific response. But once it figures out how to deal with a particular intruder, it remembers. It's like your body keeping a detailed file on each threat it faces. One way the adaptive immune system works is by producing antibodies. Think of antibodies as tiny, Y-shaped proteins that act like guided missiles. They're designed to stick to specific invaders and mark them for destruction. B cells, a type of white blood cell, are responsible for making these antibodies. Now, here's where it gets interesting. Some nanoparticles can actually boost this antibody production process. Scientists call these nanoparticles adjuvants. It's like they're giving the immune system a cup of strong coffee, waking it up and making it more alert. This property makes nanoparticles very exciting for vaccine development. A vaccine not only introduces your body to a weakened version of a virus, but also enhances your immune system's response, similar to having a built-in support team that encourages a stronger defense against potential threats. Another key player in the adaptive immune system is the T cell. These cells are like the body's special forces, trained to recognize and destroy cells that have been infected or have turned cancerous. Some nanoparticles have been found to activate these T cells directly, potentially boosting the body's ability to fight off diseases like cancer. However, it's not all smooth sailing. Sometimes, nanoparticles might cause the adaptive immune system to overreact, leading to allergies or even autoimmune disorders where the body starts attacking itself. It's like training a guard dog that ends up being too aggressive and bites the mailman. This is why scientists need to be very careful when designing nanoparticles for medical use. One fascinating area of research involves using nanoparticles to teach the immune system tolerance. Nanoparticles could effectively communicate with the immune system, instructing it to ignore specific harmless substances. Don't attack it. This could be groundbreaking for treating autoimmune diseases or preventing organ transplant rejection. As we continue to explore the dance between nanoparticles and our adaptive immune system, we're uncovering both challenges and opportunities. By understanding these interactions better, scientists hope to develop more effective treatments for a wide range of diseases, from cancer to autoimmune disorders. It's a complex field, but one that holds immense promise for the future of medicine. Nanoparticles function like miniature spacecraft, navigating through the complex landscape of our body. Just like how different spaceship designs affect their missions, the properties of nanoparticles greatly influence how they interact with our immune system. Let's break this down in a way that's easy to understand. First, let's talk about size. Nanoparticles come in various sizes, and this matters a lot. Think of our immune cells as security guards. They're really good at spotting and catching medium-sized intruders, about 20 to 100 nanometers. Smaller nanoparticles might sneak past unnoticed, like a mouse slipping under a door. Larger ones, on the other hand, are easier to spot and remove, like trying to smuggle an elephant into a room. Shape is another crucial factor. Swallowing different shaped candies is similar to how our cells interact with various nanoparticle shapes. Round ones go down easily, right? It's the same with our cells. They find it easier to engulf spherical nanoparticles compared to oddly shaped ones. It's like our cells are playing a game of Pac-Man, and round particles are the perfect snack. Now, let's consider surface charge. Nanoparticles can be positively or negatively charged. Positive ones are like magnets to our cell membranes, which are negatively charged. This strong attraction can lead to the cells gobbling up these particles quickly, but it might also harm the cells. Negative particles, however, tend to be ignored, allowing them to float around in our body for longer. The material nanoparticles are made of matters too. Some materials, like gold, are like well-behaved guests at a party, they don't cause much fuss. Others might be more like troublemakers, stirring up a strong reaction. Some nanoparticles are even designed to break down over time, like biodegradable plastics, which can help reduce long-term effects on our immune system. Scientists can also modify the surface of nanoparticles, like giving them a special coat. One popular coating is called PEG, which acts like an invisibility cloak, helping nanoparticles avoid detection. However, using this trick too often might lead our body to create antibodies against PEG, making the cloak less effective over time. Other clever modifications include attaching specific molecules to nanoparticles, like adding a key to unlock certain cell types, or disguising them with bits of our own cell membranes, a classic wolf in sheep's clothing strategy. Understanding and fine-tuning these properties is crucial for scientists. It's like having a Swiss Army knife of nanoparticles, each designed for a specific task. By controlling these characteristics, researchers can create nanoparticles that either work with our immune system or slip past it unnoticed, opening up exciting possibilities for targeted therapies and better drug delivery. It's a delicate balance, but one that could revolutionize how we treat many diseases. Let's dive into the exciting world of how scientists are using nanoparticles to revolutionize medical treatments. Nanoparticles act as microscopic assistants, collaborating with our immune system to combat diseases in revolutionary ways previously thought impossible. One of the most promising areas is cancer treatment. Traditional cancer therapies often struggle to tell the difference between healthy cells and cancer cells, leading to nasty side effects. But nanoparticles are changing the game. Scientists have created smart nanoparticles that can zero in on tumors like tiny guided missiles. These clever particles not only attack the cancer directly but also wake up our immune system, teaching it to recognize and fight the cancer cells. It's like having a personal army of cancer-fighting ninjas in your body. In some studies, researchers have used nanoparticles to deliver bits of tumor material directly to special immune cells called dendritic cells. Think of it as showing our immune system's wanted posters of the bad guys, helping it spot and eliminate cancer more effectively. Other nanoparticles are designed to supercharge our T cells, the immune system's elite warriors, right inside the tumors, boosting their cancer-fighting powers. But it's not just cancer where nanoparticles are making waves. For people with autoimmune diseases like multiple sclerosis or rheumatoid arthritis, where the immune system mistakenly attacks the body, nanoparticles could be game changers. Scientists are exploring ways to use nanoparticles to teach the immune system to chill out and stop attacking healthy tissues. Nanoparticle treatments could potentially allow people to manage their conditions and live normal lives without relying on constant medications and dealing with their side effects. Vaccines are getting a nanoparticle makeover too. Traditional vaccines often need multiple doses and can be tricky to store. But nanoparticle-based vaccines could provide stronger, longer-lasting protection with fewer doses. This could be a huge help in global health crises, making it easier to get vaccines to people who need them. For allergy sufferers, nanoparticles offer hope for a sneeze-free future. Researchers are working on ways to use nanoparticles to gradually expose the immune system to allergens, teaching it not to overreact. It's like slowly introducing your overprotective guard dog to the friendly mailman. Even organ transplants could benefit from nanoparticle technology. These tiny carriers could deliver anti-rejection drugs precisely where they're needed, reducing side effects throughout the body. And let's not forget about our gut health. Scientists are exploring how nanoparticles could deliver probiotics and other beneficial substances directly to our gut, helping maintain a healthy balance of bacteria and boosting our overall immunity. As we continue to unlock the potential of nanoparticles, the possibilities for improving human health seem almost limitless. It's an exciting time in medical research, with nanoparticles leading the charge towards more effective, targeted treatments for a wide range of conditions. The future of medicine might just be microscopic. The world of nanoparticle-based therapies is like a frontier town in the Old West, full of promise, but not without its dangers and challenges. While the potential benefits are enormous, there are significant hurdles to overcome before these tiny medical marvels can become a regular part of our healthcare system. One of the biggest concerns is long-term safety. Think of nanoparticles as tiny visitors to our body. Some are designed to break down and leave, like biodegradable plastics. But others might stick around for a long time, like house guests who overstay their welcome. Scientists worry about what happens if these particles build up in certain organs or tissues over time. It's like trying to predict the effects of a new food additive. We need to be sure it won't cause problems years down the line. Another challenge is the complexity of our immune system. Our bodies are incredibly diverse, and factors like age, gender, and pre-existing health conditions can all affect how we respond to nanoparticles. It's like trying to create a one-size-fits-all clothing item. What works perfectly for one person might not work at all for another. This variability makes it tough to predict how nanoparticle treatments will perform across different populations. Sometimes, our bodies might react to nanoparticles in ways we don't want. It's like introducing a new species to an ecosystem. You can't always predict the outcome. In some cases, nanoparticles might trigger allergies or even autoimmune disorders, where the body starts attacking itself. That's why scientists need to be extremely careful in designing and testing these particles before they can be used in patients. The regulatory landscape is another big hurdle. Nanomedicine is a new field, and government agencies like the FDA are still figuring out the best ways to evaluate and approve these treatments. It's like trying to create traffic laws for flying cars. The technology is so new that the rules haven't caught up yet. This can slow down the process of getting promising treatments from the lab to the clinic. But don't lose hope. Despite these challenges, the future of nanoparticle immune interactions in medicine looks bright. Researchers are constantly coming up with innovative ways to overcome these obstacles. One exciting approach involves using artificial intelligence and machine learning. By analyzing vast amounts of data from previous studies, these smart computer systems can help predict how different nanoparticle designs will interact with the immune system. It's like having a super smart assistant that can quickly sort through millions of possibilities to find the best options. Scientists are also developing smart nanoparticles that can change their properties based on their environment. These particles might be able to adapt to different conditions in the body, maximizing their benefits while minimizing risks. It's like having a Swiss Army knife that can change its tools depending on what job needs to be done. Advances in imaging technologies are giving researchers an unprecedented look at how nanoparticles behave in the body in real time. This is helping them gain insights and make more accurate predictions about how these particles will work in patients. Collaboration is key to overcoming these challenges. Scientists from different fields, biology, chemistry, engineering, and medicine, are working together to turn promising lab results into real-world treatments. It's like assembling a dream team, with each member bringing their unique skills to solve complex problems. As we continue to unravel the mysteries of how nanoparticles interact with our immune system, we're getting closer to a future where nanomedicine could offer highly targeted, personalized treatments for a wide range of diseases. While obstacles remain, the potential rewards make this journey worthwhile. We're paving the way towards a healthier, brighter tomorrow, where tiny particles could make a huge difference in people's lives. As we've explored today, the intersection of nanoparticles and the immune system is not just a fascinating scientific endeavor, it's a potential game changer for medicine. From enhancing cancer therapies to revolutionizing vaccine development and even preventing organ transplant rejection, the possibilities are vast. However, with great potential comes great responsibility. The challenges we face, like ensuring long-term safety, understanding individual immune responses, and navigating regulatory landscapes, are significant but not insurmountable. The research in this field is advancing rapidly, and as we continue to unravel the complexities of how nanoparticles interact with our immune system, we stand on the brink of breakthroughs that could redefine healthcare. The future holds incredible promise, but it's essential that we proceed with caution and thorough investigation to ensure these innovations benefit everyone safely. Thank you for joining us on this journey into the world of nanoparticles and their impact on our immune system. If you found this video enlightening, please give it a thumbs up and share it with others who might be interested. Don't forget to subscribe to our channel for more exciting content exploring the latest in science and technology. Your support helps us continue to bring you insightful discussions and discoveries. Until next time, stay curious and keep exploring the wonders of science. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.